Okay, students, nice to meet all of you here. It is the wonderful time that I invite you to my wonderful teaching today. Okay, um, in this class, we are going to discuss about complex Hilbert space. Complex Hilbert space. That's what we are going to discuss. Okay, complex Hilbert space. What is that? Now let me minimize that to our eyesight. Then only we can understand exactly what is displayed there. Okay, it's somewhat small. Okay, so but anyhow, let it be, because if I put like this, it goes above the screen, so it is very difficult. So why not I put like this? Okay, that's another way. Okay, now let me talk about complex Hilbert space. Complex Hilbert space. Okay, first of all, suppose that H is a Banach space. We know what is Banach space in your postgraduate study. You might have studied that. This Banach space is called a Hilbert space. It has to satisfy these three conditions. Okay, a Banach space H satisfies all these three conditions. Then we say that the Banach space is called a Hilbert space. Hilbert space. Yes, new name we are giving there. That's called Hilbert space. What are the three conditions? What are the three conditions? The first one, the conjugate of x comma y, where x comma y is nothing but the inner product we are defining here. So this inner product, for that we are taking the conjugate, that must be equal to y comma x, the inner product of y and x. The first condition. The second one, look at that. The first element is alpha x plus beta y comma z. Now this inner product must be equal to two sum of the two inner products. What are they? X z multiplied by alpha plus y comma z multiplied by beta. So sum of these inner products must be equal to this, where alpha and beta are or we call it as scalars, and x comma y comma z some elements in the Banach space H. Coming to the third conditions, the inner product of x to itself must be equal to the norm of x square. Okay, so if these three conditions are satisfied, then we say that this is not just a Banach space, but it is a Hilbert space. A new name we are giving. That's called. Since it is described on the complex space, we call it as complex Hilbert space. Complex Hilbert space. So understanding point is that a Banach space H is said to be Hilbert space, then this Banach space should satisfy these conditions. Where x comma y is called the inner product. We know what is inner product. In the previous video I was explained to you. So the inner product of the conjugate must be equal to the inner product of y and x. Second one, the inner product of this and this is nothing but the sum of these inner products. The inner product of x to itself must be equal to the norm square of x. A good example we are taking as the Banach space consists of all n tuples of complex numbers. Okay, that is x equals x1 x2 x3 dot 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 xn, and y equals y1 y2 y3 yn Those are the two elements. Then the inner product of these two is defined like this. Okay. Then we are defining a norm. Norm of x equals sum of norm of x squared to the power by 2. Then this Banach space consisting of all n tuples of complex numbers become a complex Hilbert space. Okay, but we have to define the inner product like this. The inner product of any two elements must be equal to the sum of I1 to n xi yi conjugate, the product of xi by yi conjugate. If we define like this, definitely this Banach space consists of all n tuples becomes complex Hilbert space. With that, we come to the end of this class. In the next class, we will be discussing another topic. Till then, goodbye.